Hello guys, welcome to the Bright Agent. Today I'm going to jump in straight to Pythagorean Theorem. Ensure you like, subscribe and you comment so I can reach my 100 subscriber goal and beyond. So now let's get back into the video. So you may be asking yourselves, what's the Pythagorean Theorem? Although I'm pretty sure a lot of you will know what it is. Well, the Pythagorean Theorem is essentially a theorem devised by Pythagoras himself to find any side of a right angled triangle. So, essentially, this is the theorem, and you're probably just going to say it with me at the same time. So, 3, 2, 1, go! A squared plus b squared equals c squared. It's not really a very hard thing to remember, and if you just see a question crop up in GCSE Maths or just in your regular Maths textbook or question, then you just plug in the thing a squared and b squared equals c squared. But let's say you need to find a squared or b squared because you already found c squared. Well, since a squared can even be either the opposite or the adjacent, and this can be the adjacent or opposite. It just depends on what angles correspond against. So if the angle corresponds here, this is the opposite, and the angle corresponds here, then this is the opposite. So either one can be opposite or adjacent or opposite. So essentially speaking, since C is the largest side of the triangle, being the hypotenuse, like this, in the triangle, as you can all see over here. So since C is the largest side, that means you can just do to find b squared, to find b, just b, not b squared, just b. So what you do is c squared minus a squared equals b squared. And then afterwards you just square root c squared minus a squared. However, a better way to do this would just do square root c squared minus a squared rather than just doing it after. You could just plug in the values, square root it, and then you get b, rather than just say, hey, you got b squared, and then you realize you have to square root it. And it's the same with c squared minus b squared equals a squared. You could just do square root c squared minus b squared, and then you get a. It's honestly a really simple formula. No gimmicks, no additional confusing things, nothing. It's just essentially a theorem that many foundation students can use, and hopefully the vast majority of high students like me can use. So, essentially speaking, really important theorem, but it's really simple to use. There are a few things that can trip you up though, so we'll be moving into SOHCAHTOA. So essentially, SOHCAHTOA is essentially sine x equals O over h, cosine x equals O over a, and tan x. No wait, cosine x, which equals a over h, and tan, which equals O over a. Sorry for confusing you guys there. I just kind of made a mistake on it. But let's dive into the action. So sine over h, so that's going to be sine x equals opposite over hypotenuse. So if you're trying to find the hypotenuse, if you're trying to find the opposite, it's really simple, since if you're finding x on the top, then you could just take x and then afterwards, no, if O equals x, no wait, if O equals x, then you could multiply the hypotenuse by sine whatever angle you have in there. So it's essentially hypotenuse times sine angle. And then, if O is x, then you've essentially found your answer. But if the answer is on the top, one way to do it is just flip the fractions around. So, say for example, that now h equals x. And then you have no way of figuring it out. Actually, you do. You can flip the fractions around because, well, if you just get a set of fractions and say that they're equal to something, if you flip them around, they'll still be equal. For example, if you're getting 1/5 equals 2/10, if you flip them both over, 5/1 and 10 over 2 are still 5. So flipping them over is still fine. So in this case, you'll get 1 over sine x, and then you can do h over o. So then you can do a sneaky trick, and then remove the o, and then put it on top as the numerator. So it's essentially opposite over sine x equals h. And then you get your answer. So it'll be x or y or z equals something to either 1 or 2 decimal places, and it's quite rare that they'll say you should give it in 3 significant figures. But the golden rule is just to do it in 2 decimal places, just so that they know that your answer isn't too short but not too long. So 2 decimal places is the golden rule. Now, that applies the same rule with cosine x, which equals the opposite of the adjacent, and tan x, which equals... No wait, cosine x equals adjacent of a hypotenuse. Sorry again. And tangent x, which then equals opposite over the adjacent. That essentially applies the same thing, but then the question is, how would you know? The answer lies between which angles you're essentially using. So, if it involves a hypotenuse, then you know you can rule tan out, since tan doesn't involve a hypotenuse. It only involves the opposite and the adjacent. So then you look, and then you realise if it involves the opposite or the adjacent. So you essentially have to assume most of the time that the opposite is the shorter side length of the right angle triangle. In that case, let's say it is the shorter side of the triangle. It is. Then you've got the hypotenuse. And congratulations, you've got sine x equals over h, which is the sine part of it. Or, if you got the adjacent part of it, well, you've got the cosine part of it. But if it didn't involve the hypotenuse at all. Not at all, not one bit. And it was something about something about a right angle triangle, and you got the length or some of this of like at least one side, and you got at least one angle. Congratulations, you've got tan. All you have to do is just work through that rule, memorize all the names and their properties of a right angle triangle, and you will do well in those exam questions and the real thing. Come the real thing, you won't make any mistakes if you practice this well enough. And practicing makes perfect, so just always get the hands-on practice you can get, and you will excel in those kinds of questions. In fact, it applies for everything. You're not just aiming to say, oh, I got 2 out of 3 on this question about Pythagorean Theorem. Where did I lose that 1 mark from? Well, that's mistakes you can do at home. but not mistakes you can do in the real thing. So it's important to practice this, since so many people get this wrong. I sometimes myself get this wrong. So I have to practice, you have to practice, we have to practice to get this all right, and to ensure we get 3 out of 3 or 2 out of 2, or if it's an extended question that you sometimes get NXL or whatever, 4 out of 4, whatever, although I'm not really sure since I do AQA. But anyway, whatever exam board you're doing, whatever you're doing, just remember that Pythagorean theorems are very important, and that SOHCAHTOA is very important. Remember that. Be bright, stay right, and I'll see you on another glorious day. Ensure you like, subscribe, and comment. Thank you so much.